Another method of solving that we talked about was factoring. And so example 5 here says to find all the real solutions of 2 sine x cosine x minus cosine x equals 0. So it's important on the factoring ones that they are set equal to 0 first. Otherwise, you cannot factor anything. So in this case, it is equal to 0 already, and both terms contain a cosine. So we can factor out a cosine x, and that would leave us with 2 sine x minus 1. So we know from factoring from earlier in the year, once you have your factors, you just need to set them both equal to 0. So either cosine of x equals 0, or 2 sine x minus 1 equals 0. So essentially, these turn into those basic solving problems. So again, you can look on the unit circle. You can look making a triangle, which this one is going to be a little difficult because you don't really have a triangle with a side of 0. So you might be able to look on your graph at this, so look at your y-intercepts. So for this one, this is at 90 degrees, which is pi over 2. And again, it said to find all the solutions, so we'll put a plus 2k pi with it. Cosine also equals 0 at 270 degrees, or 3 pi over 2. And again, we'll put the plus 2k pi with it. The second one then, we need to move the 1 to the other side and divide by 2. So sine of x equals a half. This one is a little bit more apt to making a triangle, because we'd have sine is opposite over hypotenuse, so that's our 30, 60, 90 triangle. And so that takes place at the 30 degrees, which is pi over 6 plus 2k pi. And the other place would be 5 pi over 6 plus 2k pi. So again, if it asks for the principal roots, that would just be your pi over 2 and pi over 6, because those fit in the domain of arc sine and arc cosine. But when they need all the real solutions, you can grab those other two example or solutions as well. For this second one here, we have 3 cosine squared x plus cosine x minus 2 equals 0. So I know that this looks bad, but really this is just a quadratic equation. And so you could use a u substitution if you prefer that method. So you could let u equal cosine x, and so then that would turn this into 3u squared plus u minus 2 equals 0, which looks a little bit easier to factor. So that would factor into 3u and u. Or if you prefer the factor by grouping method, you can do that too, but I'm a guess and checker. So I think if we put the 2 here and the 1 there, this would have to be positive, and that one would have to be negative. And so in that u substitution method, we'll then put the u back in. So we'll put the cosine x back in there. And then again, we're back at that basic solving. So we'll set cosine, I'm going to do 3 cosine x minus 2 equals 0. And cosine x plus 1 equals 0. So cosine x equals negative 1. So that's at pi, or 180 degrees. And again, it's at all the solutions. So we're adding the k pi to it. Actually, we need a 2k pi on this one, since it's cosine. There we go. For the second one, that's going to give us that cosine equals 2/3. Which is not an easy solution to make a triangle from or to look on a graph. And so this one, you're going to have to do the inverse in your calculator. And your book will tell you which mode that you should be in. I did mine in radian mode, and so I got that x was 0.8411. And again, we'll put plus 2k pi with that. And the other place that we're allowed to look for cosine is in quadrant 4. That's where cosine's positive. So we would have to take 2 pi, which is 6.28 roughly, and subtract off that answer. And I got 5.4421 plus 2k pi would be your other answer. So this one, has 3 answers as opposed to the other one that just has the 4 over there.